Hurricanes, hailstorms, tornadoes, and wildfires. These are just some of the weather hazards that displace families and disrupt lives. Many of us are familiar with the scenes of devastation these hazards cause, and the recovery process for affected communities can take months, even years. In the most extreme circumstances, some may never be whole again. This may prompt many of you to ask what's being done to reduce the risks associated with these hazards. To answer this question, the Insurance Institute for Business and Home Safety presents the Disaster Discussions podcast. Join me, your host, Rachel Penton-Goche, as I sit down with professionals in the insurance, science, construction, and resiliency industries who help us explore the intersection of these hazards with the built environment. We'll bring you in-depth conversations with experts from across the country and highlight how science is engineering real-world solutions from home and business owners to create safer, more resilient communities. Join us for these discussions every month, and to make sure you don't miss an episode, go subscribe to the Disaster Discussions podcast on your favorite podcast app. We also invite you to engage with us on social media to ask your questions, share your thoughts, and to learn more about the IBHS mission. Welcome to the Disaster Discussions podcast, where we explore the intersection of weather and the built environment. I'm your host, Rachel Penton-Goche. And in September, Hurricane Helene became the 8th Category 4 or 5 hurricane to make landfall in the United States since 2017. The intensity, fast-forward speed, large wind field, and its deep tropical moisture brought significant and life-threatening impacts well away from the immediate coast, inland to southern Georgia, Tennessee, the Carolinas, and Virginia. Rainfall ahead of Helene, combined with the storm itself, created a recipe for disaster along the eastern slopes of the Appalachian Mountains. And IBHS is home to research on our 4 perils: wind, hail, wind-driven rain, and wildfire. And once we perform the research, a big part of what we do is communicate the results to our members in the insurance industry, our partner organizations, the media, and to homeowners and the public. So on this month's episode of Disaster Discussions, we're diving deep into the communication challenges of messaging for such an historic event. Joining me on the podcast today, Dr. Giammanco, Managing Director of Standards and Data Analytics and our lead research meteorologist here at IBHS, and our special guest today, Brad Panovich, Chief Meteorologist for WCNC TV. Welcome to the podcast, guys. And Brad, we'll start with you. Tell me a little bit about yourself, a little bit about your background.
So, yeah, I've got, I've worked in all parts of the country, but I spent most of my career here in the Southeast. Grew up in Ohio. Big fascination with weather, like a lot of meteorologists at an early age. 6 years old, grew up with a big blizzard and just kind of fell in love with it. So worked in the Midwest, spent time in Dayton, Ohio, Traverse City, Michigan, where if you love lake effect, that's a great place to be. You get lake effect from every direction up there. And then moved down to New Orleans. I spent 4 years in New Orleans working at our sister station before moving to Charlotte about 21 years ago now. So been here 21 years. So a lot of experience with tropical meteorology, really got kick-started in New Orleans and then continued here into the Carolinas.
Sounds like we have a little bit of a similar trajectory there. I also was a meteorologist in Ohio and Louisiana, and now I'm in the Carolinas. So yeah. The interesting weather certainly has followed me everywhere. And so to get to today's topic, I want to talk a little bit about kind of the early hurricane season before we get to Hurricane Helene. So this was one that was much talked about, especially in the media, as we had pre- and early season forecasts calling for above normal activity. Of course, we started with Hurricane Beryl in July, Category 1 hurricane that made landfall in South Texas. Big tornado outbreak from that in Louisiana, over 100 warnings issued with that one. Then we had Hurricane Debbie after a bit of a lull in early August. That Category 1 made landfall in Florida. We later got some rain here in the Carolinas from that one. And then we had Hurricane Francine in early September. That Category 2 storm making landfall in Louisiana and bring Louisiana its first storm in several years. And I want to start with some of the challenges of communicating these seasonal forecasts. We know that despite what these forecasts say, it only takes one storm to change your perspective of the entire season if that one storm happens to make landfall where you live. So Brad, how do you go about messaging these seasonal forecasts leading up to and during the early part of hurricane season before things really typically are active?
Yeah, they're really hard to communicate because a lot of times, at least in the media, one of the things I think we do a poor job of is we immediately say that a lot of storms equals bad season. Well, yes, the more storms there are, it does give you more opportunity, but it doesn't tell you where those storms are. As you just mentioned, it only takes one storm to be a bad season. You think of Hurricane Andrew when it occurred. I think that season had 7 total storms, but one of them was Hurricane Andrew. And then we've had other very busy seasons where a lot of the storms are fish storms. They end up being steered out to sea and we don't see a lot of impact. So initially, I hate when we just immediately go to bad because people anticipate all of the storms that are in the forecast are going to have some kind of impact on them. So that's a difficult part. The other part is these forecasts come out so early in the season. And like we saw this year, when there's lulls or we're not in the heart of the season, people ask, where are the storms, right? Because they think they're supposed to happen in some kind of order and all throughout the hurricane season. But like we saw this season, which was a very unique season, we saw this really fast start, then this big doldrum area in the middle where nothing happened, and then all of a sudden this late season spike. So communicating that is hard to tell people that, hey, the storms aren't going to all happen in some sequential order in throughout the season. They're going to happen in bursts like this. And so that I think is a very difficult part of communicating the seasonal forecast, at least.
Yeah, no, after Debbie made landfall, we really had that lull through middle and late August when we tend to see most of our activity and started hearing people kind of write the season off. And of course, as we know now, things turned out quite a bit differently. Now, Ian, you provide our forecasting support here at IBHS. You do a lot of media interviews leading up to hurricane season. You're on air talking about a lot of this as well. What is your communication strategy for these forecasts as the season kicks off?
Yeah, Brad hit it too. When we're talking about public communication, I think we try to keep hitting that it only takes one message. And to be honest, if you ask somebody who's been through, say, one of the really terrible events, and even just any storm, that's the most active season for them they will have experienced. And so trying to get that across to everybody that, hey, just remember, take these with a grain of salt because we can't guarantee landfalls. But there is value to these seasonal forecasts. And in our world, in the insurance and risk space, there are financial risk management tools that are tied to these. There's parametric insurance products in the commercial space and reinsurance that go with them. But now, if you think about all the data access the public has for weather, it's been out there, right? These forecasts have been around forever, and everybody gets to see them. And they generate interest, which I actually think is a good thing initially because it does allow us to be able to get that preparedness information out there. But Brad hit it too. Like when you get the lulls, there's some expectation, right? That the when we say active season, that means there's a storm headed at us all the time. And when it's not, we're kind of sitting back like, why isn't this happening? Well, this season's, a dud. And I started to wonder in the middle, I was like, are we really going to hit the hyperactivity numbers? You have to start really looking at, what's driving the ship from the atmosphere and ocean. But again, we saw 2 big peaks in sort of spurts and activity. Some of that was Madden-Julian oscillation tied to, and others you just happened to get that Western Caribbean gyre feature that just turned the switch for like 3-4 storms in a row. And they're all, especially down there, there's not a whole lot of places to go that there isn't land in the way. So that's sort of what unfolded this year.
Right, and as we know, Hurricane Helene developed in the Northwest Caribbean Sea later in September. It was Monday, September 23rd. It was named Potential Tropical Cyclone 9 before moving northward into the eastern Gulf of Mexico, then strengthened into a Category 4 hurricane. And Helene eventually made landfall as a Category 4 in the Florida Big Bend area on Thursday, September 26th. So, Ian, early on, a lot of the attention around the storm focused more on Tampa Bay, particularly the storm surge potential for that area. We have an office, an IBHS office down in Tampa. I know you were providing some forecasting support for our colleagues there. And at one point in the Helene Ops Slack channel that we had, you started mentioning models were bringing in Helene as a sub 930 millibar low. And you said this was, quote, cause for a bit of that stomach tinge from this meteorologist. I take it you started getting a little bit of a bad feeling about it. You provided forecasting support for our field team as well as they deployed the PIPS tower in Florida. So what was going through your mind as Helene approached Florida? Why did IBHS choose to deploy on Helene, and what was our research goal with this storm?
Yeah, so our focus this year from a research aspect has been collect wind-driven rain measurements through a unique deployable 10-meter big observing tower that's got a very unique piece of instrument on it called a precipitation particle imaging probe, or PIPS tower as we refer to it, that can, one, tell us the droplet size distribution in high wind environments. It's meant to go on aircraft, and it's something we don't have a lot of testing standards for in our wind-driven rain element, and it's a big cause of loss where water comes through windows and doors and really any sort of wiggle room in the building envelope you can think of, and we don't understand a lot about it. So that was our research objective. So we went after Debbie, Francine, and Helene was our 3 deployments this year. For the first time, IBHS having an active hurricane field research program outside of a post-event damage assessment. So Helene was our 3rd storm. And our focus, like many people, right, was the immediate coastal environment. That was our mission. That was our research mission. We had folks at our Tampa office, so we're dealing with business operations there. So our focus was pretty narrow from an IBHS research and operations perspective to the coastal environment. As it turned out, Helene made landfall in about as least a populated area of Florida as you could sort of throw a dart at. And it did have some wind at landfall too, but as we'll talk about here in a minute, the most catastrophic impacts actually occurred well inland. And again, I think it sort of speaks to, while we were operationally focused on the coastal environment, I think everyone's eyes when we talk about hurricanes often are drawn to the coastal environment and those coastal places. And we often forget about what happens when this entire big mass of tropical moisture and a big low pressure system moves inland. And then, like Helene, you add in terrain. And of course, we got a catastrophic outcome.
And Brad, you previously worked in Louisiana at WWL. As you mentioned, you covered Hurricane Katrina, which we now know a major communication challenge, maybe one of the biggest in U.S. history. And you've covered numerous storms for the Carolinas here in Charlotte, or the Charlotte DMA, as we say in local TV. You have a few million people to potentially communicate with on any given day, not to mention a few 100,000 followers on social media. So at what point did it become apparent to you that Helene was going to impact your area of responsibility? And when did you start messaging that to your viewers?
Oh, pretty much early on. From the early, when it was a potential tropical cyclone, we knew at least the moisture was going to come to the Carolinas at some point. Obviously, at that point, you don't know the amount of precipitation, the wind, all those other hazards, but you knew we were going to see some indirect impacts. And one of the things, and Ian brought this up, is there was so much focus on Florida and the coast. And we get, and this has been going on for years, there's this hyper focus from the public on the cone, right? Where does the center go? And what I tried to do early on with this system, because the cone looked like it was going west or going a certain way, was not to focus on that, but focus on the swath of the impacts, right? So the impacts were huge, especially on the east or right side of the storm. As we all know, the right side's the dirty side, the worst part of the storm. There was really no way that we were not going to see any impacts if this thing was anywhere near us or to the west. And I think at one point I even mentioned, if this thing even went to Memphis, we were going to see impacts in the Carolinas. And so really started messaging that hard from almost the beginning of the track, because and also remember, the track only goes out 5 days. So that's the other thing. People think what happens after day 5 isn't really explicitly put into the track or the cone. And so you always got to focus, okay, yeah, this is the 5-day cone. It takes it up into Western Florida, but where does it go from there? So there was a lot of messaging about what those impacts were going to be for us long term. They weren't as really extreme at the beginning, but we knew we were going to have some type of impacts here in the Carolinas for sure. And then they really started ramping up 2 to 3 days ahead of time when we saw that predecessor rain event, which we really recognized right away. And that's when, at least for me personally as a meteorologist, I knew, we're going to have some big problems here because of that predecessor rain event.
Yeah, I know that was mentioned in our meteorology channels here at IBHS. Ian starting to mention a few days in advance, you were getting a bad feeling about the Appalachians. And Ian, in Helene's case, this looked like it would be an intense storm at landfall for Florida. But as you mentioned earlier, despite Helene's rapid intensification, especially in the 6 hours before landfall and observations from those Hurricane Hunter aircraft sampling some of those extreme winds, they didn't really translate to the surface in the form of those peak gusts for Florida. On the flip side, we later saw Hurricane Milton, which intensified into a Category 5 at one point and was a 4 on its approach to Florida. So with Milton, forecasters knew it would weaken prior to landfall. So kind of opposite situations there. How do we best go about communicating differences in intensities, especially with storms that we know are going to weaken before landfall?
Yeah, this is, I'll take us across the board here as a group, and I think we should talk about this. It is one of the biggest challenges that I think our field faces, is dealing with understanding impacts at landfall, forecasting them better and more specific, but also dealing with these storms that do change in intensity and impacts on small timescales. We know, think about us in the South with snow. Brad, I know you talk about this all the time where we latch onto a snowfall forecast 5 days in advance, and then we don't come back to it. I'm going to use a personal story with Milton. My in-laws live in St. Pete, and my mother-in-law was here at our house, and she could not get off of fixated on the fact that Milton was a Cat 5, and she was literally having anxiety, almost panic attacks, knowing that both her son-in-law and her daughter are experts in this field. She still couldn't get past it. And I sat there, I made some social science notes. I'm experiencing this firsthand, and there's very little I could do to tell her Milton is not going to be this at landfall. There's a lot of shear coming. I don't know what it's going to be, but it's not going to be this. In the case of Helene, where we see this sort of the winds not really reflected at the immediate coast, then we had some synoptic sort of influence coming along with kind of the extratropical transition. I don't know what we're supposed to do in terms of trying to get people, hey, the inland part of this, including wind impacts, is going to be really serious. I think about southern Georgia. Helene was their second hurricane. Michael was their first major hurricane. And this is not coming from the coast. This was an inland impact into southern Georgia. And I honestly, I think about, we've done so much social science work to really illuminate where our holes are, but we're still struggling to find sort of the things that work. And I'll turn this now to you, Brad and Rachel, because you guys have done this, you do this for a living. What does work? We think about really all the spectrum of this kind of severe weather.
Yeah, I was going to say, I think the difficult part with Helene, and I even saw this pre-Katrina, there's that saying, your level of preparedness is only good as your memory of the last disaster. And the problem is for so many people, they have no memory of anything like this happening. And so I could say, I could make the best social science graphics, wording, but if you've never experienced it, you don't think it's real. And we saw a lot of this with Helene in the mountains, where even days ahead of time, you're saying catastrophic flooding, you're saying catastrophic impacts. This is the worst flood since 1940 or 1916. But there's not many people alive from those two floods, or even people that remember those. And so it's hard to tell them what is this going to mean? What does that mean to me? And so I think it's a problem for us, but it's also a problem from a society standpoint, that their imagination of these extreme events just can't go there. And so it's really hard for them to grasp the impacts that they're going to see. So yeah, I'm with you, and it's hard. It's I thought a lot about this after Helene, what could we have said or done differently? And in some cases, I don't know if it would have mattered, because of just, this has never happened to these people, so they're not going to really understand it. And so that was the difficult part for us, especially in the mountains.
Yeah, I faced a similar situation, Ian. A family member in Florida frantically texting me about Milton, saying, I'm hesitant to evacuate because I know most of the hotels north of me are full from Helene, but I'm looking at the storm. It's a Category 5. It's coming right towards me. And I said, no, you are fine. You need to stay. You do not. In her case, I think it would have been a bigger threat or a bigger headache to actually evacuate and be stuck in all that traffic and stuff like that. I was like, you're going to be fine where you are. So I think it's just getting people to truly listen and understand those details and take the time to really let them sink in and think, how will this direct me? How will this impact me directly, if at all, kind of getting into those minor details there. So I want to talk about Helene moving inland. And on September 24th, 2 days before Helene made landfall in Florida, the National Hurricane Center had this messaging in one of their forecasts. They said, quote, due to the forecast's large size of the system, storm surge, wind, and rainfall impacts will extend well away from the center, particularly on the east side. And in addition, the fast forward speed while it crosses the coast will likely result in further inland penetration of strong winds over parts of the southeastern United States after landfall. So we did hear from the National Hurricane Center about those inland impacts, but once a storm makes landfall, their job is more or less done. I interviewed Bill Reed earlier this year on the podcast, and that's what he said. I said, what is it like covering these storms? And he said, well, once it makes landfall, I go home, I'm done with my job. We're more or less finished after that. So Ian, we know the NHC is a trusted voice. Should they play a bigger role post landfall, especially for events like this one that do end up doing more damage away from the coastline?
Yeah, this is something I think the Weather Enterprise, specifically in the NOAA NCEP National Weather Service space, is going to have to wrestle with. I can sit here as a private sector meteorologist who isn't in the operational forecast chair and play Monday morning quarterback all I want, but I do think it's become very clear over time. And talking, Bill's a personal friend. I've known Jack Bevan at NHC for quite a while. They are a trusted source of information. That's become very, very clear. So should they have a bigger role post landfall? I actually think so. It's very hard for Brad. You run into this when we were living in Rock Hill. I would talk to my neighbors like they had no idea who our local office of the National Weather Service is. They're going to get information from people like Brad. I think about Brad and Brittany over at their station. That's who the information's coming from. But in hurricanes, it's very different. I remember as a kid, like Bob Sheets was my hero. I just, I wrote a goal as a little kid to be the director of the Hurricane Center because I loved listening to Bob Sheets. And it's different. So I do think there's a role NHC can play in continuing maybe the briefings that the director or deputy directors do. Like we think about the handoffs to the local WFOs or even the Weather Prediction Center. Nobody knows those entities. So now you're reliant solely almost on the broadcast community as your almost singular form of information. And we all talk about, right, it's better to have multiple ways to digest this information. But I just wonder, because of the trusted source nature, that maybe there is an expanded role the Hurricane Center could play. And then that's my Monday morning quarterback. And like these extreme events, right, we learn more looking at it post, because when we're trying to respond, we're going by the playbook we've got, right? It's muscle memory at this point as these events unfold. But after the fact, it's always important to take a look back at what was working, what maybe we could add that could help. And like we mentioned, I don't know what actions we could have recommended, especially once we get into the mountains of the Carolinas. I don't know. I just distinctly remember even being very concerned. My sister-in-law lives in the North Georgia mountains, and I was like, this is going to be really bad. And the same thing could have happened over there that happened more on our side in the Carolinas. But I just sit here scratching my head. Like, I know there's some options, but I'm not sure once we get beyond that, what are the guidance steps we could have even offered? But I'll turn it over to you guys and we can talk about this part a little bit more.
Yeah, this is the difficult part. I mean, the inland areas, and I really started thinking a lot about this after Florence and Matthew here in the Carolinas, because we had these massive inland flood disasters well inland. And from a media standpoint, something I actually brought up with my bosses, which I wish I would see more of the national media do, is what do we do when we cover a storm? We send all our reporters and live reports to the coast, right? And so whether I'm saying there's inland impacts or not, the perception we're giving is people standing in front of palm trees on a beach, making it seem like it's a coastal event. And I actually talked to my boss, said we need to start pre-staging or doing live shots from inland areas that are prone to flooding. So like the Lumber River here in North Carolina, which flooded in Florence and Matthew. And so I did see one outlet send someone to Asheville pretty early in the event and start reporting nationally from that location. And so I think that just the perception that we give is really important, that, hey, this is going to be an inland impact. If we're there covering it, then it raises the awareness that this is an inland impact. The other thing that I think has changed, and I think I agree with you, Ian. I think the Hurricane Center needs to play a bigger role in this. Was after Sandy. We saw all the issues with Hurricane, Superstorm Sandy, whatever you want to call it, where because it became extra tropical, all the advisories and warnings went away when they really didn't need to. And so I think there needs to be more of that. We're seeing some of that now with inland hurricane and tropical storm warnings, and there's some new development with the cone now showing the warnings inland with the cone. There's a lot of things. Those are small things, but they're coming from the Hurricane Center, I think carries a lot of weight because people see that. I'm not a fan of the cone because of some of the things it doesn't say, but let's be honest, it's probably the most viewed piece of weather graphics that anyone in this country has seen, because that's all you see everywhere when there's approaching hurricane. And almost instead of fighting it, sometimes I feel like we should use it and try to make it better and show more of these impacts well inland, and maybe that will actually help in the long run. And maybe the longer cone, I know that's coming. We're going to have 7-day, forecast cones, and maybe in my lifetime, 10-day forecast cones, who knows? But those at some point will come, and maybe there's an extended cone that shows a looser cone, but also shows impacts. So that would be something I think could be really useful.
Yeah, I agree with you, Brad. I think going back to how do we get people to listen, how do we get people to understand that the things will impact them, anyone in the cone, I feel like is hyper focused on the fact that they could be impacted, whether they're on the right or the left side or inland. I think the cone is a good way to get the general public to pay attention when they see their city, highlighted in that color. And that's really interesting about the national media you mentioned. We've all seen the memes on social media during these storms. I think the perception for a lot of the general public is, if Jim Cantore or et cetera, is in my area, I'm going to be impacted. So I think seeing a national reporter in some of these smaller towns ahead of these events, when we know that they're going to be impacted, I think that is a great idea to draw attention to that.
So I want to touch on that, because I saw there was I think a graduate student did some social media analysis early on. I think it was Milton, but it could have been Helene too, where it was specific related to Jim and where he was at. He was in the Tampa metro. And the amount of social media traffic that started talking about how whatever storm, I think it was Milton, was going to make landfall in Tampa because he was there, it like rocketed up in volume. And now you've started a almost inadvertent train of misinformation simply because of the perceived nature of how we cover the kind of event. So I thought that was really interesting, and I'd never seen it reflected in social media data before. But sure enough, but in Brad knows that you move around to try to offer what you think is going to be the best coverage, especially from the Weather Channel perspective, which their job, right, is to cover the weather. I'm never going to fault them for putting 9 people in the field, because that's their niche, right? Like that's their job. But I found it very interesting to see that people's perceptions can actually change simply because they are paying attention. So they did one thing, like we'd be happy that, hey, you're clearly following this, but you made an inference based on a piece of information that wasn't actually part of the real forecast just because Jim was there.
Yeah, we've seen some of that in tornado coverage, and a lot of the social science people take a lot of cues about how I act or look when we're covering storms, and I've seen a lot of this. Like people joke like when I take my jacket off or roll your sleeves up, or they know it's serious. So in some cases we need to like lean into that. Like we've got this ability, like whether we know we're consciously doing it or not, we are sending signals to the public about how serious a storm is. One of the things that I appreciate is when it's going to snow and people say, hey, when Brad says it's going to snow, it's going to snow, because I appreciate that. But when there's bad weather, you got to kind of use that same thing, right? It's like when we're saying or doing something, we're actually triggering the fact that this is going to be a serious event. And so I think we got to be more conscious of that. And I know Jim is, like I said, I see a lot of that almost every storm, there's like fake pictures of Jim in like 5 airports at the same time, right? And you're like, wait, he can't be 5 places at the same time. It's almost like maybe this is where AI is going to help Jim out. They can use AI Jims and put him all over the place to warn everybody in the path of the storm.
That would be a wonderful use of AI.
Yeah,
we can use it to our advantage.
of AI.
I would say too, Rachel, we deal with this at IBHS too. If you think about our staff, it's mostly, while we do have, I think we're up to 7 or 8 meteorologists on staff, that's still a very small subset of all of our staff. And we have a campus that's in the coastal environment in Tampa. But I think, our job is when all of us start using a little more gravitas or language around an event. I know Roy Wright, our CEO, talks about that. Like when we get concerned, then that's his cue that I need to be concerned about this event. And we're pretty tempered about that. IBHS, we have operations to worry about, and then our event response and research elements, and the communication side. But I think that tells you something. Like, I think about severe weather. I have a lot. My sister lives in the Dallas-Fort Worth area. I have a lot of friends still there from graduate school. But I hear a lot of sort of the mixed messaging aspect during severe weather out there, where I get messages like, what in the world is today going to have for severe weather? And it's like, people will say, like, I can't discern anything from anybody. And so there's sort of the antithesis, the negative aspect. If we're so all over the board, how do people feel out, as Brad mentioned, that body language where we become a little more serious about the event? I think that's a serious challenge that we face. It reflects itself a little more, I think, in severe weather coverage, because it's, you can be under a tornado watch all day, and if you have, and you could have a perfectly sunny day. Like the end result could be, hey, I shouldn't have disrupted anything because it was nice out, and a county away had a tornadic supercell or something like that.
Yeah, definitely. I mean, as a former broadcast meteorologist, I had, viewers tell me, I could tell by your voice that it was getting serious. They have those certain cues, whether it's, a physical cue or a change of pace or voice or tone. People do really pick up on those things. And that could be the difference between, them half listening and them actually taking action. So like Brad said, I think we do need to lean into some of those things that work for us. Everyone in Alabama knows, that when James Spann's sleeves are rolled up, it's going to be a busy day of severe weather. So, there's things we can lean into for sure. Well, I want to talk about that predecessor rain event. We talked a little bit about it, but that set up before Helene made it to the Carolinas and actually produced up to 10 inches of rainfall in portions of the North Carolina mountains. And it became evident that Helene would bring even more rainfall as well as wind to some of these same areas. And Brad, my question for you is, did the fact that this was a tropical system influence perceptions of how bad Helene would be? I know you said you started messaging it early on, but how do you handle messaging with the hurricane when you know that the inland impacts are going to be the worst?
Yeah, the hard part was the timing. So when the predecessor rain event's going on, a lot of folks are immediately asking, is this the storm, right? And in some ways, as bad as the predecessor rain event was, it was actually a nice wake-up call for a lot of folks like, hey, all this rain we just got, this isn't even the storm yet. So think about how bad this is going to get. So in some ways, a predecessor rain event caused and contributed to a lot of the damage, but it also gave us a really good early warning to like how bad this was going to be. And so for me in particular, that Tuesday, I remember building the graphic and trying to show how wide this predecessor rain event, and here's the storm. It was still near Cancun at the time, right? And so it was easy to tell people, look, we're getting all this rain. We had 6 to 12 inches of rain in between Tuesday and Wednesday. And this isn't even Helene yet. So that actually helped in the communication. And in a weird way, as bad as it was, it helped people like recognize, wow, we've already had flooding. We've had a ton of rain, and then it's going to come. I experimented with some different graphics this time. As I mentioned, I kind of was tracking the whole swath of impacts instead of just throwing the cone up all the time. And even before the excessive rainfall outlooks came out, I actually drew my own ahead of theirs because the timing was right with the excessive, extreme rainfall in the Western Carolinas. So a lot of that predecessor rain event was kind of like a good cue for us as meteorologists, but also was a great tool to be able to use to say, hey, this is going to be a bad event because you're seeing this now, and the main show isn't even here. That's coming, Thursday night into Friday morning.
Yeah, really interesting. Certainly a way to that hopefully drew people's attention to this event if they weren't already drawn to it. Besides the excessive rainfall, another big factor, of course, we had multiple tornadoes produced inland by some of those thunderstorms, including several tornadoes across North and South Carolina. And then, of course, we had those incredibly high inland wind gusts, a gust of 92 miles per hour at Mount Mitchell State Park, 76 miles per hour at Frying Pan Mountain. The most intense winds occurring in Buncombe and Avery counties in North Carolina on those southeast facing slopes, especially at those higher elevations, at 80 to 90 mile per hour gusts with pockets of 100 plus miles per hour along the Blue Ridge Parkway, Black Mountains, and around Roan Mountain. So, Ian, you partnered with the National Weather Service after the event to do some post-event analysis of these winds. So what did you learn from that? And from a forecast perspective, I'm curious to know, how did the meteorology community do in forecasting and communicating these wind impacts for some of those mountain areas?
So this one presented a big challenge for operational forecasters, because we know a bit about inland decay of tropical cyclones, but we also had a larger scale synoptic system influence and produce what we believe was sort of this sting jet feature, which is an acceleration of kind of lower level winds in response to the changing structure of the system as it interacts with a bigger, broader trough. These sting jet features can materialize sometimes, and then other times they don't. And a lot of times they're also not reflected down at the surface where we live. But in the case of Helene, you ended up with a wind maximum. We worked with the Weather Service in Columbia, so a big shout out to Matt Gropp there, who really kind of kicked this off along with John Corgiello there in that office. But working with some of the surrounding offices, we're looking at some of the very intense tree damage from the areas kind of southwest of Augusta all the way up into the Midlands of South Carolina. And we got some data from a couple of the private sector weather radars and ran what's called a velocity azimuth display calculation. So it gives you a vertical profile. And sure enough, as Helene's passing, you get this 120 mile an hour jet feature that's fairly down low, a kilometer-ish, maybe a little lower. You can transport that momentum down to the surface, and then you add in the terrain, and you start to realize, oh my goodness, that's why we saw such massive tree fall damage along the ridge lines, that kind of second set of ridge lines of the Appalachians. One, from the sting jet. Two, you get natural terrain speed up effects over these ridge lines. That's something we've known in wind engineering for a long time, and a lot of places have building code adjustments to account for things like that. But you had this storm where Helene's, moving inland, sort of the tropical aspect starting to weaken. The wind field is expanding. And then somewhere around Valdosta, things just changed where the synoptic influence kicked in and you get this sting jet feature. And sure enough, we found it in the radar data. And it's led to really this sort of enhancement of what we think occurred in terms of near surface gusts. And then think about it as you go up in terrain. So that wind max, I'm using my hands for folks who could see the recording, but video, wind max is up here. Say you bring your hand up closer to it as the terrain comes up, it's going to be a lot easier to move that momentum over a shorter depth. And that's exactly what happened. And tree damage, outside of the flood impacts from our insurance loss world, the tree damage claims are going to be ginormous. We talk about this at the lab and sort of in our hallway conversations. Trees are good as windbreaks. We've known that for centuries until they're not. And the drought, our drought conditions, we had sort of weakened vegetation as a whole combined with the predecessor lead up rainfall event, and throw in gusts 90 to 100. And this is exactly what you're going to get is a wide swath of really catastrophic tree damage.
Yeah, some of those aerial drone photos of the homes located up on some of the ridge lines. It looks like someone dumped a box of matchsticks out around these homes, just no trees left standing. Brad, this was some of the most devastating loss of timber in the history of North Carolina. Is that right?
Yeah, it's just the videos you were referencing just blow my mind. I was actually spent a lot of time up there after the event, and one thing that struck me, and I don't know if you've been up there, Ian, but these trees aren't snapped. The whole tree is down. I've never seen that much damage where the whole tree, root ball and everything, are just all blown down. And that had a lot to do with the predecessor rain event, but also tells you how long those winds were pushing on those trees. And so, it's just wild. I've never seen that much tree damage in an event like this, and the timber is just crazy. All the loss of life, a lot of it was flooding and fatalities, but we had a lot of loss of life for tree fall. I mean, especially outside of the mountains, that ended up being one of the biggest causes of death in this event. You would have thought the floods or the landslides would have done it, but a lot of tree falls on cars, on people, on homes. And so that really was just something that kind of, honestly, I knew there'd be wind, but that type of wind was kind of something I was not anticipating seeing. And then we really didn't know it was going on because one of the things about the mountains, such a remote area, there's not a lot of wind sensors. The trees were kind of our wind sensor for us. They told us what was happening. And so it was easy to guesstimate how high those winds are just by looking at the trees. They're damage indicators for you. But we weren't getting a lot of information about that tree damage until after the fact. And a lot of that was just his communication, which was a big issue all around. But once those the lines of communication were out, we were losing not rain gauges, but also anemometers. So you really didn't know how strong these winds are. And the radar coverage in the mountains is always bad. So a lot of that was not known until we actually got drones and were able to fly over these areas.
Yeah, that's a great point. I mean, we lost most of the ASOS surface observations thanks to the power outages. It's something, I remember as a graduate student at Texas Tech, we talked about, like, in typical hurricanes, you lose like almost 60 to 70% of the observations you have just because of power loss, which we still haven't remedied. And that was one of the things in talking with the Weather Service in Columbia, that we just had no observations to go on. And then from the products that, say, our insurance risk sector uses, which is a lot of wind field modeling applications that leverage these observations, we just missed because there simply was no data until after the fact where we can go look at tree fall characteristics just like we do for tornadoes and derechos and things like that. But this was massive. As Brad hit in the mountains, you were dealing with the big oaks and poplars just completely toppling. Further south into the Midlands, you just had massive pine damage. I think about southern Georgia, the ag losses are going to rival Hurricane Michael. What Michael didn't get from the pecan orchards, Helene did. So you have this huge ag loss in southern Georgia from this. And it's going to take a long time for some of those, what are beautiful forests. This is all of our homes, and a lot of us go up there to that part of the world regularly. And we're actually, at the time we're recording this, we'll be driving through that area going over to North Georgia for Christmas. That's where we usually go see family and go for Christmas. So it'll be pretty impactful to take a look at some of the things I've seen from the imagery and data standpoints. But this presents a really big forecast challenge because I don't think yet scientifically we quite know enough about how these decaying tropical systems we have good inland decay and we understand extratropical transition, but these are smaller scale features that do translate to impacts at times. And it's our job to figure out what those impacts are and be able to talk about them and also understand what is the damage potential that can come from them.
Yeah, and Brad, as a broadcast meteorologist, it can be tough to communicate some of these extreme events and in these, more remote locations, particularly when they do become these once-in-a-lifetime generational events like we're talking about here with Helene. So how do we best communicate the extreme of an extreme event, and how do we do it without crying wolf, so to speak? This particular event reminds me of Harvey. I worked in Louisiana for many years, and I know that was something those meteorologists grappled with as they began to see in the modeling, historic rainfall totals. It's hard to go on TV and tell people that a historic event is about to happen. You kind of have to balance it with a lot of common sense as well. So just how do you best communicate these extreme of the extremes?
Yeah, that's the hard part. The good news is I think the tools to illustrate what these are going to look like are becoming more accessible to us as broadcasters. I mean, one of the things I love about being a broadcast meteorologist is that we've got this cool technology to build amazing graphics. And now we've got 3D and semi-realistic graphics. We can show people what this is going to look like to a certain degree. Call it CGI or Hollywood or AI. But I think that's something we can actually leverage so people can imagine. You mentioned Harvey, and the interesting thing about Harvey, I remember that because 50, 60 inches of rain, people think it's like snow. They just think that 56 inches of water but that's not. It runs off, and that ends up being feet and feet of water. And so that's really hard to describe because, even for Helene, you say 30 inches of rain. Well, what does 30 inches of rain mean? Well, over a terrain like the Western North Carolina, that's horrible because that's all running off into the valleys and the gullies. So I think some of the technology we have can make it easier. But we also now have these lessons. Like, trust me, we're not going to have to warn people in the mountains again about our tropical system for the next generation or two because they all have this memory of Helene. But what we can do is for folks that don't live in Western North Carolina, we can use this as an illustration like, hey, remember what Helene did to Western North Carolina? If this storm is heading to, say, the Northeast, we get a storm in the Northeast, or it's heading towards Texas or another part of the country, we can say, hey, look, this is an example of what this can do. And so I think we should take these lessons from the storms that have happened recently and use them to explain future systems. But the problem is there's always going to be a first system, like the worst ever for some folks hasn't happened yet. And so I think that's something you got to keep reminding the public, like, hey, I know you've lived here 40 years, 60 years, 70 years. You have not seen the worst weather. Trust me, it could still happen. You haven't been here long enough to see this. And so I think that's something that we got to illustrate to people, that your personal experience may not be a good gauge of how bad something could be.
Right, and I want to bring up another point. One thing I saw this event described as in the media a lot afterwards was, that the mountains of the Carolinas were supposed to be the climate refuge, or whatever climate refuge is. How do we communicate that? Because as we all know, these days there is no such thing as a climate refuge.
Yeah. I mean, you saw a lot. Asheville was like always highlighted as this, like, because they have this perfect weather. It doesn't rain too much. It's not too cold, not too hot. But it goes to show you, nowhere is really safe from extreme weather. I think that the thing that we have to remember, especially in the Southeast, is our biggest influence on our weather are those mountains and the Atlantic Ocean and the Gulf of Mexico. Our proximity is part of the reason I live here, that I love living here, but it's also the reason we get such crazy weather. And I think people think that beach or that coast or that ocean is really far away. It really isn't in an atmospheric standpoint. And you take that much moisture and push it into the western part of North Carolina, you're going to get these huge, huge rainfall events. So, yeah, I think we got to be careful with those. Like, they're safe places to live, and because everybody has their severe weather, right? You've lived in different places. I have. There's different types of severe weather. If you live out west, it's wildfires or it's flash flooding or mudslides. Unfortunately, one of the things that makes the Carolinas a great place to live is also what makes it a crazy place for weather. We get just about any type of extreme weather possible here. And I enjoy it as a meteorologist, but it makes it very difficult as a homeowner or a business owner, because this means you have multiple threats or hazards you're going to have to deal with. And Ian talked about the tree fall. I immediately kept thinking about the wildfire danger that we are going to have now for years in the mountains with all of that timber that is down. So something that we do have a fire season. I think people know about it, but I think in the Carolinas, this is going to be a heightened thing we're going to talk about every spring, summer, and fall for probably the next 5 to 10 years.
Yeah, I'm going to jump in on that one, because anytime we're going to get a flash drought, that fire concern is going to rocket up across the area impacted by Helene. Thankfully, we talked about this after Hurricane Michael with all the pine damage inland over the panhandle of Florida into southern Georgia. Thankfully, that actually didn't materialize. And the one thing we do have going for us, we often deal with the flash drought scenarios. Our long-term droughts are actually usually broken by tropical systems. Yeah. Helene, another example. So we don't typically, and I'll say typically because it does happen, we often don't see the long multi-year drought conditions like the Western United States does, but that's driven by the larger scale circulation issues. But anytime we get into a flash drought pattern, really probably over the next, you could almost draw it out over a decade, we are going to end up in a very enhanced fire risk. And it does worry me for places like Asheville. I think about the mountain communities, Hendersonville, even the larger towns, even over into mountains of North Georgia, up into Southern Virginia as well. And I'll tell you now, the concept of defensible space in those communities is non-existent from a wildfire mitigation scenario. So I'll throw out a little bit of our work in wildfires. These big catastrophic fire events in communities often occur with droughts at any time scale, and then wind and people. And people is usually the ignition source. And so if you put those three together, that probability for a catastrophe can go way up. So I think that's something we're going to be worried about for quite a while in this part of the world as we head, I think over the next decade, really.
Yeah, that was a big problem after Laura. Millions of acres of timberland fell in the inland parts of Louisiana, and that was followed by a flash drought in the 2022 to 2023 season, and over 500 wildfires in Louisiana, which was unprecedented. Huge wildfires. Luckily, there was no loss of life, but that was a big problem following Laura due to all the just millions of timberland. And another interesting thing that I learned after that particular event was that timber is a source of retirement income for a lot of folks. They live on properties with timber that they have plans to sell this and make money in their retirement years. So not sure how many folks in the Carolinas, had that as a plan, but that was just one of those unusual kind of lasting impacts from Laura that we saw in Louisiana. Just kind of trickle down things that you don't even think about that come about after these storms. So I want to talk more about the historic rainfall. Anywhere from 20 to 30 inches of rainfall fell in some of the mountains. That catastrophic flooding I mentioned earlier in western North Carolina, and two of the hardest hit areas, Avery and Buncombe counties, which is where Asheville is located. And this was some of the most severe flooding in recorded history for Avery County. Hundreds of homes and businesses flooded and destroyed. Widespread road closures, bridges completely wiped out, completely saw roads and even a couple of towns more or less completely washed away. Landslides, another big impact from the heavy rain. And almost 100% of these areas were left without power and water. As we saw and heard, communities were completely cut off from society due to some of these roads just being totally washed out. Of course, that unfortunate loss of life. And we could see this take years to rebuild in some of these communities. So going back to the devastating flooding, Ian, this was the result of a combination of factors, and you guys have talked about it a little bit, but tell me some more details about how exactly this rainfall event unfolded.
I mean, some of it really just, there's a degree of randomness where you get the axis of precipitation right along the proper ridge lines of the Continental Divide. And where does that water, and Brad mentioned it, we can talk about 30 inches of rain, but that's feet in river, creek, etc. rises, and it has to go downhill. Gravity is not going to stop, and this is what you end up with. I mean, I think even in Rock Hill, we had the Catawba, even with the dam flood control systems that the Catawba system have. I mean, you had water right under the interstate bridge there in Fort Mill, and just the volume of water. People always underestimate, unfortunately, what water can do. Water has so much more mass than air. I talk about that with storm surge and hurricane winds. Just a block of water has way more mass than the same block of air. And it can do some unthinkable modes of damage. And if we think about, you place that swath of rain right over the right spot, our roads in that, in the Appalachians follow these small creeks because that's just sort of the natural place you can actually fit a road in, other than getting up on top of a ridge line and perhaps sort of you think about the switchbacks and things going up the terrain. But, and that's where we're going to build our small communities too. These are historical communities. They've been around for a long time. And they were put there on purpose because of the source of water. But unfortunately, in this case, when all of it has to run downhill, you get this kind of outcome, unfortunately. And there was a degree of randomness that does occur. It's does that axis end up in the exact worst spot? I mean, I think about, we can rewind the clock, flip it to Katrina in a storm surge scenario. We know that little corner between the mouth of the Mississippi and the Mississippi coast is the most ideal place for storm surge in the United States. And if you just get the track right, you can get just these absurd impacts. And a lot of times they don't happen. And in this case, from a rainfall standpoint, it does. And this is what you got. And there's where the challenge lies, is I don't know what, we can talk about the impacts. I don't know what kind of guidance there was to even help prepare people as an action to do, because this is a volume of water that I think about the flood level in the Biltmore, the entrance to Biltmore, topping, what was it, back in the early 1900s, that flood event. I don't know the date off the top of my head, but that's a previous generation, right? Nobody's going to remember that. No. You see the sign, right? You see the placard, and maybe you stop and look at it for a second, but you don't digest it. And so when they happen, we know this with a lot of perils. When you get the right situation, everything comes together for a catastrophic outcome.
Yeah, and I think you brought up a good point there about the randomness, but also just I mean, it's like you compounded things. You had, impact upon impact upon impact all lined up at the same time. And one of the things that struck me after the fact, I thought a lot about this afterwards, is, that predecessor rain event dropped anywhere from 6 to 12 inches, but that was over a 2-day period. Then Helene came up, and that axis of moisture dropped another 6 to 12 inches, but that was in about 6 to 8 hours. And when you're in a mountainous terrain, in some of these areas, the water was literally just running down the face of the mountain. There was nowhere for it to go. That morning when I was up all night. That morning we're on air. One of the first things that struck me is we had a live camera of downtown Boone, North Carolina. It's on King Street. King Street is nowhere near a creek, river, or stream, and there's brown, muddy water just flooding it. And I knew right away, I'm like, there's no water source near there. Where is this water coming from? I knew it was coming off Howard's Knob. There had to be a landslide. But that's the kind of stuff you saw. Places where normally water shouldn't be running, it was running because there was nowhere for it to go. The other thing that struck me, and I've thought a lot about this after the fact too, is when you look at the terrain and the topography, like I think of the Chimney Rock Gorge or the Linville Gorge, these topographic and geographic features were built by water. This is where the water has run for years, and why that gorge is there, because water slowly eroded it. And at some point, that water is going to fill that gorge again. And I think for a lot of folks, because it hasn't happened in our lifetimes, it's hard to imagine that. Where did these big boulders come from that are in the Broad River? Well, the water pushed them there. You think they're gorgeous stones, but water at some point flooded deep and strong enough to move it. The other thing that struck me, and this is something when I was up there, is you mentioned this, the volume, the force of water was something I've never seen before. It wasn't just water rise, it was the velocity of the water that struck me. Seeing steel girders bent around trees or cars bent by the force of water, that to me is what also struck, was the speed of this was very, very intense. These were the epitome of flash flooding, where it went from a trickle of water to a torrent in a matter of minutes. And so that's something that's really hard to warn for, because as we know with the ASOS, every river gauge was gone. You don't even know from a remote standpoint where the water levels are on some of these creeks and streams, and most of them don't have gauges to begin with. So it's really hard for the warning process. And so I thought the Weather Service did a great job of just blanketing the whole western part of the state with flood emergencies, because they just knew it was bad, and that was the best way to get the messaging out.
So I pulled up a stat really quickly. 1 cubic meter of water is half a ton.
Wow.
If you think about just a simple cubic meter, a cubic yard, whatever you want to look at it that way from the English units, from a visualization standpoint. But that's an awful lot of mass. And even moving at a slow speed, much less probably flow rates 30, 40 miles an hour, maybe. I'm not a hydrologist. That is a boatload of energy, because you're squaring it by the speed it's moving. And that just sort of puts it into perspective. That's just a cubic meter, cubic yard of a block of water. When you add in the velocity component, you're going to push structural things to their design limits really, really quickly. And then add in a duration and fatigue element. And I'm actually a little surprised we didn't see more complete structural failures of some of the bridges and perhaps even the dam systems, because we know, a lot of these dams, some of them are privately maintained, others are old Tennessee Valley Authority things, or we have some of the Duke Energy System things, but you're going to push some of the design limits. When you look at, we designed to return periods. That's what we set engineering design standards on. And when we go push this past whatever that is, so think about wind, we designed for a 0.14% probability of the event happening in a year, which is a 1 in 700 return interval. From a rainfall perspective, we pushed way out there on the tails. So I'm actually surprised we didn't have even worse infrastructure failures than we did, just considering the sheer load that was placed on some of these features.
Yeah, and I want to talk about some analog examples. We always like to compare things that have happened to things that have happened in the past. And for the Carolinas, I know I was not around for this one, but Hurricane Hugo is often the comparison for tropical events. So I'm curious, how does Helene compare to previous storms? Is Hugo a good comparison, or did Helene set a new precedent?
That is an interesting one, because I think we kind of hit it, because human behavior hits the benchmarks in your head. Hugo, I mean, I remember moving to Rock Hill, and everybody in that area around Charlotte, Rock Hill, it talks about Hugo, who's lived there for a while, that was the benchmark windstorm for the Carolinas. I do think when you get probably down into the Midlands, this is going to feel like that to most of those folks, that this is going to be their Hugo benchmark event. And of course, as Brad mentioned, from the flood aspect, anybody from, moving up the all the way up the slope of the Appalachian, any of the communities, this one's going to stand out for a generation, for sure. And probably both the wind and water. I think the wind probably surprised a lot of folks. And it does worry me, like that you're going to create an awful lot of anxiety when we get the big synoptic storms that do produce pretty strong winds up in the terrain. You are going to generate a lot of anxiety around that for people who dealt with this. And that's going to be another sort of secondary challenge that comes along with how we as humans deal with these kind of events.
And Ian, here at IBHS, our members are made up of the U.S. property and casualty insurers. So we talk about flood insurance a lot, and particularly the need to educate the public on flood insurance and how it works. And we say here a lot, if it can rain at your house, it can flood. So we know many, if not most of the folks affected in these communities likely did not have flood insurance. So can you tell me about the perceptions around the need for flood insurance? And do you think Helene will now change these perceptions, especially for those inland communities as we go forward?
Yeah, so the events always sort of drive the flood insurance awareness. And I'm going to actually correct my stat. Our cubic meter of water is about a ton, actually. I did the wrong unit conversion, so bad scientist, Ian. You should be better than that. On flood insurance, the inland penetration of flood insurance is really poor. We just don't think about it. And you'll hear us at IBHS talk about anywhere it rains, it floods, and you should have it. And flood insurance, actually, if you're out of the FEMA designated flood zones, they have different demarcations for that. Flood insurance through NFIP is actually really, really affordable. We've always carried it, but it's something. Think about this. I live in high terrain. Why do I need flood insurance? Why do I need it? I'm not even at fault anybody for that perception. Why would you think that you did? Unless you live this stuff like the three of us, sitting here do. It's something that's just out of mind until it's not. And events do drive the upticks, but that's my one piece of encouragement, that anywhere it rains, it can flood. And man, having just some degree of safety net, in those kind of cases can help. I know a lot of people in the paycheck to paycheck, you have to make really hard decisions on stuff like that. And I wish I had a better answer. I wish I had an answer for that. But if you can, it's a good place to look. Hey, I'm not in a flood zone. This is really affordable. And I have heard some of the new private sector flood insurance options through your typical insurance carrier that you'd have your homeowner's policy through. Talk to agents about, because some of them are actually becoming really, really affordable and good coverage that can get you past like the minimum limit or the maximum limit that the NFIP program has, which for a lot of us who own a single family home, I think it's $250,000 is the cap. So if you're beyond that, in a lot of our single family homes, just think of the real estate market and how it's changed. You may be beyond that, even though you paid half of that. Your home value now may be past it. And you're not going to, the private market might actually give you that full coverage. So ask some questions. when we talk, Rachel, we talk about how to communicate the frustrations of insurance and to try to put a silver lining on it. I can't tell folks that it's not something that's just not annoying, or you just don't think of it, and it's kind of like, oh, I got to go deal with my homeowner's insurance.
Yeah,
you got to just get in a habit. And luckily, you guys know my wife. My wife usually keeps us honest, so she keeps us on track. But it's made me realize, like, hey, you just have to keep up with something that is one of those things. And I'd encourage folks to check it out. Just check out NFIP, check out the private flood market, talk to your agent about that. And that safety net could really mean the difference between a complete disruption of your life versus, hey, this is still really bad. This is really annoying and frustrating and hard, but I don't have to move or something like that. Oftentimes that's what happens. We see it time and time again if we just look at mortgage delinquency rates following catastrophes. The recovery is so hard. People end up having to sell and leave those communities. And it doesn't matter what hazard we're talking about.
Did you have some thoughts on that, Brad?
I would just say, insurance, nobody likes to deal with insurance. But I will tell you this, the one thing I've learned in my career is water damage is by far, I think, the worst damage you could have to your home. It's not easy to fix. It's sometimes, I remember after Katrina helping my friends clean their house out, and it came across their mouth many times. They almost wish their house had burned down because it would have been easier emotionally and physically to just rebuild the house. The problem is you're gutting it, you're smelling it. It's like you feel like you're in a constant state of always something being done instead of just starting from scratch. And so if there's one thing I would tell you is you don't ever want to have flooding. To me, it's probably the worst damage you could have to your home. Yeah, and I've had small water leaks and they're horrible, right? Just under your sink. Imagine your whole home. The other thing is Ian made a good point, and it was funny. I got a new car, and so our insurance went way up, and so we reshopped our insurance for the first time in a long time, and lo and behold, like Ian said, didn't realize we didn't have the proper coverage for our home because we were going to bundle it with our homeowners. And so I think it's important. I've said this since that's happened to me. Constantly be shopping and checking your insurance policy. What does it cover? How much? Because you are right, Ian, with the value of your home going up, you may not have enough coverage. The coverage is there to rebuild the house of what it was when it was, put there. It's not always for current standards. And so you got to be very cautious. So I definitely would say, check it out. But as you mentioned, I think the western part of North Carolina is a unique area. Some folks don't have insurance in general, let alone flood insurance. And we're seeing that, unfortunately, in the recovery where folks, this is their small plot of land they've had for generations. They put a simple house there. They couldn't afford to cover it with any kind of insurance, let alone flood insurance. And I don't think we would ever get anyone to buy flood insurance on the side of a mountain. It's just something that doesn't seem like, if I'm going to cut costs, that's the last thing I'm thinking about. And again, this extreme event thing is we talk a lot about the recurrence frequency of a rainfall event, 1,000 year. I wanted to go and calculate this, Ian. Maybe you should do some. It's more than 1,000 year return for this one. It's just that's where the table goes, right? It probably is in the 3,000 or 4,000 year range. But that's also hard. It's a hard thing to communicate. Like, why am I buying insurance for something that's supposed to happen, 1 in 1,000 years? Or, as we know, there's a 0.1% chance of that happening in any given year. But that's not the way it's communicated. So it's really difficult to get people to do these things. It just gets to the point of things that don't happen frequently or don't happen in your lifetime. It's just hard to cover it with insurance, hard to grasp, hard to communicate. And so it's something we're going to constantly have to deal with, I think, going forward, as more of these extreme events are happening. And not only are more of them happening, more people are living in areas where these happen. Most of the Carolinas are transplants, right? I run into this all the time. If you're from the Northeast or the Midwest, I still get people that move here, guys, that tell me they heard tornadoes don't happen here. It happens daily. And I'm like, well, who told you that? Your real estate agent? It's like, but those are the things people don't grasp. They're not from here. So it even makes it harder to communicate, because not only do they not have a lifetime memory, they don't have a lifetime memory of here, Charlotte, North Carolina, or Western North Carolina. So that becomes an issue as we become more mobile and people are moving all over the country. They have no memory of weather or extreme climate events in any part of the country they didn't grow up in.
Yeah, I think we hear that about the population growth in Florida with just hurricanes in general, but it's everywhere. On the insurance side, I think a lot of parallels to the New Orleans metro in Katrina. You had generational homes. I grew up in South Louisiana. A lot of people don't leave. My dad's house in Luling, Louisiana, my great grandfather helped build that. Eventually, when they finally moved, but that was three generations that lived in that house. And so when you have to make those cuts and you don't have to have even property insurance, these are really hard choices. And I even think about how we deal with this in building codes when we put the onus on local communities, and they have to pick between their roads or their building codes program. I mean, what do you think they're going to pick? Like, come on, like we can find a way to do better. But it really does. It makes you realize why we all do the work we do, is to try to change this ever so slowly. This will be that generational impact that I think folks in the Carolinas will simply talk about forever. And there will be a silver lining to that. As Brad mentioned, everybody's going to be really aware the next time that inland track, whether it's coming from the Atlantic side or the Gulf side, heads that way. And I remember thinking with Milton, right? Like, people were like, please don't have this happen again. And then I think Raphael, some of the guidance early on, was kind of hinting at some of that. And it's like, oh, please, everybody, don't look at the 380-hour GFS and just let it be. But it does. It instills, there's a degree of fear. And people are going to remember it. I mean, I'm talking to my mother-in-law about the impacts in the St. Pete area from Helene on the surge side, and people were shocked in the sort of west side of Tampa Bay, the 6-7 foot surge. I'm like, you guys don't, man, the real deal is going to be double this. And how do you start building up a little bit more awareness of what's coming? So we all have, in terms of communicating this, I don't think we're going to have a long road and a lot of work to do. But I think this one pointed out some holes, but also pointed out some places where that we can lean in and actually make a difference too. I do want to mention, Rachel, I don't know, we're starting to get closer on time. Brad, you worked a lot in sort of the recovery aspect. But I want to talk about like how how terrain sort of influences that, because it does make for a huge challenge when you deal with an environment like that.
Yeah, I mean, I joked oftentimes, a lot of people move to the mountains to get away from people. I mean, that's why you go there, right? But that became a huge problem in this event, because you had one road and one line of communication to a remote cabin on a hillside. And the second that's taken away, boy, it was like living on an island, right? You're just separated from everything. And the recovery was difficult because you need big equipment to get in there. Well, there's no road to get big equipment. And even if you build these temporary roads, which you see a lot of people, that's not meant for a truck. That's meant for like a side-by-side or an ATV or even a small car, but you can't get big trucks in there. So the infrastructure part of this is really, to me, this is the part I'm not an expert on, but I was fascinated by like just the engineering to like rebuild some of these roads and some of these culverts. And I've seen some of it because I've been following a lot of it. These retaining walls they've been building with concrete, stacking them and tearing them up with like pump trucks. It's been pretty fascinating. And then one of my favorite areas, which I've been following closely, is Chimney Rock, right? Chimney Rock area, the river actually moved, and they're moving the river back, physically re-digging a channel so that the road can go back. And so those type of things, it strikes you when you get up there. That's the thing I'll tell you. If you go up there, the way that the terrain and the geography has changed, that's what first strikes you. It just does not look the same. And that to me is what's the most stunning thing about seeing some of the damage up close, is like, you've been there before and you're like, this doesn't even look like the same spot, because literally the basin for the river creek is changed completely. And we know that happens in geography, right? That's geologic process. But it happening in a blink of an eye instead of like millions and millions a year is pretty crazy to see up front.
Yeah, I was in Beach Mountain actually the Sunday before the storm, and that was really my first trip into the Carolina mountains since moving here earlier this year. And I was struck by I couldn't believe the long winding roads and just how long it took to get where we were going. It wasn't, very far in mileage, but it took a while to get up there just because the tight turns, winding roads, lots of cars headed up into the mountains. And that's all I could think about in the following days is how the heck did people get out of there? Because I mean, it was a hike to get up there, and it was hard to fathom, the impacts that those small mountain towns would be seeing and having to deal with that. And Brad, you were on the ground for some of the recovery, as Ian mentioned. So I'm just kind of curious, what has been the sense of in the mountains? Were these people? I mean, were they prepared at all? We talked about it, about the communication challenges, but what is the sense that you got being on the ground? I mean, I take it they didn't quite expect this, but were they prepared to some level, and had they had to deal with anything like this previously, as far as those challenges of moving around after the storm?
It's pretty amazing. The one thing that struck me being up there, there's such an amazing people. They're so resilient in Western North Carolina. A lot of them were caught off guard. Like, they knew it was going to be but I heard this a lot, but they just didn't think it was going to be that bad, right? It always felt like, it was going to be bad, but they could ride it out. Because you've lived in the mountains, you've rode out pretty bad storms before, winter storms, even strong cold fronts, 100-mile-an-hour winds happen quite often at Grandfather Mountain. People are used to some big events. But I think what caught them off guard was just the scale and the level and the multitude of impacts, right? It wasn't just one, it was many things. And then the lack of communication was a big thing, because people just didn't know what was going on. They hadn't heard from people, and that scared people, because they knew they had friends up the mountain or on the other side of the holler, and they just could not get information. So the lack of information was really hard. The other thing that I heard often, and I didn't really think about it until I talked to people, they were thankful this happened after sunrise. In many cases, they said the water didn't come up until 8, 9 o'clock in the morning, Friday morning. They had said if it was in the middle of the night, they probably wouldn't have made it, because they were able to see what was happening and get out and climb out of their house or get to higher ground because there was light. And so I didn't really think about it. And I started looking back at some of the water levels and some of the things we saw. Yeah, a lot of it really ramped up after the sun had already come up. And they commented oftentimes, like, if it wasn't for that daylight, they think the loss of life would have been much larger, because they even though they were shocked and caught off guard, they were at least able to see what was happening and get to safety. If it happened in the middle of the night, they don't know if they would have made it.
So there's some similar stories from Sandy in New Jersey, with the peak surge was overnight, and folks were basically woke up by water in their homes. And in this case, you have water flowing at high velocity through a structure that may not even, from a structural collapse perspective, is much more likely than even a strong or kind of moderate to high end storm surge. We know the catastrophic storm surge events can create structural collapses, but in this case, you're just adding that velocity to it too. That would be terrifying. Now that I'm sitting here thinking about that. And yeah, the infrastructure side certainly presents. In my head, I started thinking wildfire evacuations have sort of a similar challenge when you're dealing with sort of isolated communities that may, Paradise, good example, one road in, one road out. But you often, in a wildfire scenario, you're not going to lose the holistic road infrastructure like you would here. So you could still get back, but you're on an island when it gets cut off by the fire itself. And that's a challenge we face across the board in rural communities, as to how to plan. And I started thinking too, is like, what emergency manager is going to run through this playbook exercise? You don't have it. It's not in the toolbox. And yeah, we can sit here and harp on failure of imagination. And even I love, Rachel, I love running our own sort of emergency response scenarios at IBHS. Who's going to put this one together? Like, I guarantee someone will now, which is a positive.
Yeah.
But you end up in that widespread mutual aid, side where you have small communities that just aren't not ready for that whole ordeal. And I do hope, we'll use this as a learning experience. But to Brad's point, like, I love, we spend so much time between sort of the mountains of North Carolina, even South Carolina, but also North Georgia. And it's one of my favorite places, just because of people. you can go there to avoid people, but you also get to interact with folks there. And for me, it's just I talk about this a lot. I'll talk to weather to a normal person rather than a storm chaser any day of the week, especially when I'm in the field. I get to do that every once in a while out there in the mountains, and it is a special place to, especially all of us who've lived in the Carolinas for a long time. And it is good to see people helping people. It's always a story after all these events. My biggest shout out, I remember one hurricane research mission had to stay at the Salvation Army shelter on the Outer Banks. It was after, I think it was Irene. And I just sat there like, these guys are the heroes. We were just retrieving research equipment, but man, a hot hamburger and a bottle of water and I bet everything you could and a cot to sleep on. It was about everything you could ask for. I was like, you guys are, I remember just telling, I was like, man, what great work. So,
I agree. And like, this is, I've said this many times since the event, like this is the biggest catastrophic storm I've ever had to cover. I would have said it was Katrina before this, but now I would definitely say Helene. But it's also, to me, the best response from the public that I've ever seen. And I was lucky to be a part of that. I've never seen people step up and help like they did with Helene. It was amazing. To your point, we're up there. I was at the EOC in Newland in Avery County, and their normal EOC is down. It's washed out. They're up at a temporary one, which was a really good setup. They did have a good plan in Avery County. A big shout out to them. It's high ground, great communication. They get land choppers. But boy, there was churches there feeding everybody. There was food. I mean, these people just drove there. Nobody's paying them. They just came in, and that to me was amazing. And the churches, I've never seen the churches step up like they did in this event either. They're out there, they got damage and they're giving hot showers and meals to people. It was amazing. So that, as sad as some of it was to see, the encouragement of the people was like, that really made you feel like, wow, these are resilient folks, man. They don't mess around.
Yeah, some of it made me even appreciate a bit of the folks in across South Louisiana that I think have a similar attitude. And it is, I have, after being a part of, this year I think I got to 23 different hurricane research missions after Debbie that I've been a part of. And I've always thought that just watching the faith-based organizations work is pretty amazing after these events. And it's even just expanded now. And they just can move fast. And then it just becomes effort. It's can you move fast with logistics and effort? But yeah, my one experience with the Salvation Army was just pretty amazing. And I hadn't thought, and usually as a scientist, and this is personally, like, you get this internal switch. You can turn off your like emotional element, except Katrina was the one I couldn't, because I had family ask like, hey, am I going to have a home to come back to? I'm like, I don't think you're going to, as a 25-year-old graduate student. But most events, I'm like, I have a science job to do. I'm going to do it. I'm going to do it safe. I'm going to get the team there, get instruments down, and get out and do it all safe. But then you have like those moments where you have those experiences. And Annette thought about how nice it was to talk to somebody and just have a hot meal for literally a handful of hours and take a nap to get on the ferry to go back. And, what if you're stuck there? Those people are going to be your sort of lifeline for the next, month, maybe. So really big shout out to everybody who's involved in emergency response. It's grueling work, and I know people just trying to help people. And if we do more of that, I think we'll be okay.
Well, we're about out of time today, but I want to get you guys' closing thoughts. We talked a lot about silver linings, and I know there certainly will be plenty that come from this event, plenty of devastation as well. So just kind of what are your closing thoughts on Helene, from the perspective of meteorologists and just from some of these communities in these mountain communities in these places that, weren't necessarily expecting this. What do you think we'll learn from this, and how do you think we'll use Helene going forward?
I guess I'll start us off. I think so. Scientifically, I think we're gonna get a little bit more focus on inland impacts and understanding them. I actually think we should commit some research into landfall, what happens at landfall, inland decay impacts, both at the synoptic, meso, and then the local scales as a whole. We've done tremendous improvement in our forecasts. for tropical systems. And I actually think we may have turned the corner on intensity too with some of the new modeling applications that are spinning up. I think about the new HAF system. On the impacts, we'll keep communicating. I think Brad hit it. Like, we just keep trying, and we'll find those nuggets that work, and then you hang on to the nuggets, and then you figure out the ones that don't, and you just keep building that toolkit. And folks like him, like, he's one of the best to be able to keep applying what you learn. And then from, Rachel, talk about sort of the insurance loss perspective. I think we're going to hear, the renewed interest on, how do we tackle the tree damage aspect? What do we do about this? And then also the concept of inland winds in our building codes. You think about southern Georgia. Do we need to think about true code changes as a result of this? And how are these going to impact our design level wind events and our intervals that we base our codes off of? And then the broader aspect, bring in climate. How do we adapt our codes and our ability to set design standards to account for that? I know the American Society of Civil Engineers is working on that, how to integrate climate modeling into those design levels. I think we're headed in the right direction. The problem is science and engineering, we move slower than most people want. And I wish it was faster, but you also want to do the job right. So that's kind of my closing thoughts. I'll toss it over to Brad.
Yeah, I think meteorologically, we're going to learn a lot. I think the wind thing we've been talking about it's devastating, but it's also fascinating to me, the wind damage and like how this happened. And the sting jet is something we've seen in a couple other events. That's really hard to forecast. So it's like one of those things, but when it does happen, you get these huge wind events. The other thing is, I think, is going to be useful. I mean, there's always a silver lining in some of these because you can learn. And I think the rebuilding process, you hear this often, rebuild bigger, better, more resilient. I think that there's a huge opportunity to do that in some of these communities who haven't had a lot of funding for infrastructure in the past. And there will be a lot of funding available from this event, which could help rebuild things better. The other thing is I hope to see is there is a lot of meteorological data void in the western part of our state. We definitely need to address that, having more sensors, more gauges. I've been working personally with a radar project to hopefully get some better radar data in the western part of North Carolina. So I think there are some good things that can come out of this that now, when you ask for money from the government, sometimes you need a disaster like this to get that money. And unfortunately, here we are. And hopefully some of these answers to some of the requests will come true now that we can get better sensoring and remote sensing in this area to help mitigate issues like this in the future. The other thing is, I think the building code thing is very important. I think two things I think will come out of this in the western part of the state. One, people are going to really realize where they are in a floodplain more so than ever. I think they need to be remapped. I know in Asheville there was some issues about the mapping there. Also, something that hasn't really been done in a while is landslide risk, debris flow risk. Really neat. I think there's a lot of building on areas that probably aren't or shouldn't be built on because there hasn't been extensive mapping. I know the USGS is doing a lot of research right now on the landslides because I know last count there was like 1,500 or whatever landslides. I think that'll be a huge silver lining, that the mapping of Western North Carolina for landslide risk will be much more detailed and accurate. So when the rebuilding process happens, we'll be building in correct spot and be able to mitigate some of those risks and hazards in the future.
All right. Well, thank you both for joining us today. Our guests on the podcast, WCNC Chief Meteorologist Brad Panovich and IBHS Lead Research Meteorologist Dr. Ian Giammanco. Thank you so much for joining us today. And for all of our members out there listening today, be sure to check out the Hurricane Helene Early Insights paper on IBHS.org. The report offers a preliminary look at some of the impacts along the coast and inland and poses some of those critical questions that will guide future work and how communities can better prepare for extreme weather. This has been Disaster Discussions, the art of communicating science, messaging Hurricane Helene. And we'll see you back here next month for another episode. Thanks for listening to the Disaster Discussions podcast, an IBHS production. Subscribe to our podcast on your favorite podcast app or watch the podcast on our website at ibhs.org/disaster discussions podcast and on the Insurance Institute for Business and Home Safety's YouTube channel. Connect with us on our social media pages. And for more great content from IBHS, including ongoing research efforts happening at our facility and more, visit ibhs.org.